Okay, so today we're going to learn how to prepare solutions, how to make solutions. So first, it's important to realize that when we're making solutions, we generally start with a concentrated solution, and that's what we call a stock solution. All right, so in most scenarios when we need to dilute something, there will be something that's concentrated. And when we make solutions for lab, I generally don't give you concentrated solutions. I kind of water it down. I dilute it, right? So that it's concentrated enough to see a reaction, but it's not so concentrated where it could be harmful. So there is an equation for this. This is called the dilution equation. M1V1 is equal to M2V2. And so this is based on the idea that the molarity equation, we've talked about this last time, how if we needed to find moles, you could by multiplying the volume by the molarity. And so the moles that we have in a sample at the beginning moles of solute at the start will be equal to the moles of the solute at the end. The only difference is we're diluting it and adding more water, so the solution volume is expanding. So this takes on a form that is very similar to some gas laws that we saw, like Boyle's law, right? P1V1 equals P2V2. It's the same idea, right? It's based on proportionality. So in a situation where we are diluting a solution, the concentrated stock solution is usually known, right? And so the stock solution is usually this one. We know that molarity, okay? And the M2V2, this is what we want to make, or what we want to prepare. So in order to figure out what numbers go there, or in order to do this, we need to find this. This is our goal. Find V1, which is the volume of the stock solution. So let's just dive right into an example, and we do a couple of these, and I think this will make sense. So let's say we want to make 250 milliliters. We want the concentration to be 0.2 molar, and what we have on hand is 6 molar. So right off the bat, of these values that we are given, if I want 250 milliliters, this is the volume that I want to prepare, so this is V2. If the molarity that I'm trying to make is 0.2 molar, that is the end molarity. So that's M2. And the 6 molar is what you have to start with. That's M1. So here the goal is to find how much of the stock solution, or V1. So the equation rearranged, if we solve for V2, all we need to do is divide both sides by M1, and that's how we get here. Now, as far as units, the volume unit here, I know that we've been using liters all the time so far, but here you could actually leave it as liters, or you can use it as milliliters as well. So it doesn't matter, because after the molarities cancel, the unit you have left is the unit of the answer. So our desired molarity, 0.2 molar, our desired volume, 0.25 liters, our stock molarity, 6 molar. After we run our calculation, we get 0.0083 liters, or 8.3 milliliters. Okay, so this is the first part of the problem, figuring out how much. How much of the stock solution you need. But we still need to make the solution. So in order to make the solution, we need to add water to this to get it up to the final volume of 250 milliliters. I'm going to add a page in here. Just so I can show you. All right, so when we're making solutions, we use what's called a volumetric flask. And the volumetric flask has one marking on it. It's not like a graduated cylinder where there's lots of lines. There's one line. And that line equals whatever the total volume is going to be. In this case, it's 250 milliliters. So the first step, usually use a funnel, and then you add HCl, you add the solute, or the concentrated, the stock, into the flask. And at that point, so you've got a little bit of liquid in here, right? Because you didn't add a whole lot. This is the 8.3 milliliters. But here's the desired volume. So in order to make the solution, we add water. Add water until you reach the mark. And that mark is the only mark that that flask has. Okay, so let me give you a different scenario. If we had calculated that we need 8.3 milliliters of the concentrated stock solution, and if someone else says, well, why can't we just add 242.7 milliliters of water? Because 242.7 plus 8.3, sorry, is it 241.7? 241.7 plus 8.3 adds up to 250, right? Can't you just measure the water carefully and add it? And the answer is no. You can't just add the water to the stock solution because sometimes the volume shrinks or expands based on how it behaves with the concentrated stock solution. So that's why we just say measure to the line. We never measure the amount of water that we're adding. There's a difference. You guys understand that? Okay? Because even if I tried to measure 241.7 very accurately, and if I added it to the 8.3 milliliters that's in there, that 8.3 milliliters, it might work its way into the water, and the total volume will shrink. And so it won't be 250 like I wanted it to be. Or maybe they don't bond as well. Maybe the attractions are weak between the two, and that's greater than 250. So the bottom line is, you finish this off by just making sure you have the final volume. Just add water until you get to the line. Okay? All right, let's try, let's go over this. So here's another example. So this is copper sulfate solution, the blue. And so what we'll do is we'll measure the amount of the concentrated solution we need. So just pretend like this is like the 8.3 milliliters we talked about. We add it to another flask, and then we just add water. And the important thing is you don't go past the line. Because if you go past the line, your volume is greater than 250 milliliters, and then you have to start over. So just slow down and take your time, and then there, you've diluted a solution. So let's try a calculation of one. We want to make 100 milliliters of 0.04 molar potassium dichromate, and we have a 0.2 molar solution from stock. So first, let's identify what we have. What is the 100 milliliters? Which one of these variables is it? Well, it's a volume. Is it V1 or is it V2? It's V2. It's the one you want. It's the one you want, right? So that's this. What's 0.04 molar? What is that? It's a molarity, but which molarity is it? It's M2. And then elimination says that this is our stock solution. That's M1. Okay. So we run that calculation. And I'm going to leave this in milliliters because it actually doesn't matter if it's in milliliters or liters. Because since the molarity cancels out, the only unit left is the volume unit, and I can get my answer in milliliters. That's fine. So the answer is 20. 20 milliliters of stock solution. Okay, but that doesn't fully answer the question. They're asking how I can prepare this. So right now I know how much I need. Now what do I say? This was the first step. Add to the flask. 3. Add water. Now, I should mention this. When we add water to the flask, so generally I don't fill it up all the way. So here, let's draw a tiny picture here. So here's my little bit. That's my 20 milliliters, right? So what I recommend is adding water, but don't add all the water you need. Add water, half the water you need. Because that way you can swirl this and get it to mix really well. And then add water to the line. Because if you added water to the line right away, it'd be hard to swirl because you didn't leave enough space in there to mix it. So add water, swirl, and then lastly, add water until the mark. In this case, the mark being 100 milliliters. Okay. All right, using that example, try this next one on your own. Now pay attention to the fact that they're making 14 bottles. What do you guys think? How much of the stock solution are we going to need? I'm trying to make 14 200 milliliter bottles. All of them that have a molarity of 0.85. Anyone? Lexi, what'd you get?
I don't think I'm right.
It's okay.
I got 8.5.
That's gonna be higher than that. Jake?
476 liters.
476. Not liters, milliliters.
Oh, I got it in liters.
Whoa. Okay. All right, let's.
0.46.
0.476 liters, yes, right, which is 476 milliliters, yes. Okay, so we want 14 of these, right? So the first thing you need to do is multiply 14 times 200, right? So you have 2,800 milliliters, okay? That's the volume that you need. So this is V2. So the molarity you want is 0.85. We just found V2. And our stock concentration was 5 molar. Okay, so calculating, canceling the molarity, we end up with 476 milliliters because I used milliliters as my unit to start with. So that's how much I'll need. And then I put it into a flask, I add water, I swirl, and then I finish, and I keep adding water until I reach the total volume line, which is this. 2,800 milliliters. Now, I don't have a flask that exact size, but I'd probably break this up and do it into smaller chunks. Okay, so when we have concentrated solutions, this is how we figure out how we're going to dilute it. That's one way to make a solution. The other way to make a solution is if we have a solid. If you have a solid, it's a similar idea. The only difference is what you start with is not a solution. You've got to figure out how many grams you have. So let's say that I want to make 3 liters of 0.5 molar sodium hydroxide. Okay. The first thing you need to do is figure out how many moles that is so that you can figure out how many grams that is. So again, if molarity is moles over liters, then I can find moles by multiplying the molarity times liters. So this is what we're doing here first. Okay. 3 liters times 0.5 molar, I'm going to need 1.5 moles of sodium hydroxide. But in the lab, your balances do not weigh moles, they weigh grams. So we have to convert this to grams. So we use the molar mass, 1.5 times 40, and we get 60 grams. Once you get here, once you figure out the mass of the solid, the rest is exactly the same. You take the 60 grams, you put it in the flask, you add water, half the water you need, you swirl it till it dissolves, and then you add the rest water the rest of the way up until you get to the line. And that's it. So it's basically the same. You're just starting with something different. Instead of a solution, you're starting with a solid. So, how do we make this? Molar mass is 158.14. Just to save you a little time. So what's the first thing I do? Joyce, what do you think? How should I start this out?
Multiply the liters times, or 4.0 times 0.010.
Okay. So 4.0 molar times the volume. So we will need 0.04 moles. Okay. Then what? Ozzy, what do I do next? Yeah, let's use molar mass. Is 158.14 grams for every mole of the solute, the Na2S2O3. Okay, when doing that, we get 6.32, let's call it 6.33. Okay. And then, when you describe how to make this, Mahek, what do I do?
You would add salt to the flask and then add water,
Exactly right. Add it to the flask, plus water, swirl, and then continue to add water until you get to the total volume that is desired, which in this case is 4 liters. So that's how you make solutions. You can make it two ways, either from a concentrated stock solution or from a solid. How are we doing on this? Okay. Okay. All right. Then I'm going to show you how to do one different type of problem here. And we had some space here because I added a page up here earlier. So go back to where you have space. Okay. Let's say that I have a solution where the density is 1.10 grams per milliliter. Okay. And let's say that the solution is 5% NaBr by mass. I want to know what the molarity of this solution is. So this is called converting concentrations. You were given one concentration, you were given the mass percent. But I want to know what the molarity is. So, in a problem like this, it's easiest if you start by making an assumption. Do you remember back when we were doing empirical formulas, how whenever I gave you a problem that said, this is 20% sodium, this is 30% chlorine, remember how I said, just assume you have 100 grams? Because that way the percents become grams, right? So notice I gave you mass percent here. Let's assume that we have a total mass of 100 grams of solution, okay? So 1. Assume sample size. In this case, we're going to go with 100 grams. It doesn't have to be 100 grams. We can go with 1,000 grams. We can go with 1 gram. You just have to assume some number and stick with it. Okay. Now that I have 100 grams, okay, so we have 100 grams of solution. How does that 5% now become helpful? What if I said, what's 5% of 100? It's 5 grams. Do you see how, because they told us it's 5% sodium bromide, that means 5% of my solution is sodium bromide. So that means I've got 5 grams of NaBr, and I have 95 grams of water. I'm going to pause there and let that sink in. Are you guys okay with that? We said it was 5%, a 5% solution, so 5%, 5 grams out of our 100 is sodium bromide. There's 95 grams of water, okay? All right. So if I'm trying to find molarity, the formula for molarity is moles of the solute divided by the liters of the solution. Okay, so I have a whole bunch of information on here. Which one of these two values can I find next? At least find most easily. The moles or the volume? The moles of the solute? What's the solute? Is it the NABR or is it the water? It's the NABR. What do I know about the NABR? There's 5 grams of it. Can't I turn grams into moles? Sure can. All right, so 79.9 plus 99. So our molar mass of sodium bromide, we'll have to divide this by 102.9 grams. Okay, and that's going to be 0.0486 moles of NABR. Okay, so we have the moles now. We need to find the volume of the solution. What's that number I gave you in the top left? This top left. I gave you the density. The units on density are grams per milliliter. What could you do with the density if you have the density and if you have the mass? We have both the mass of the solution because we assumed that we had 100 grams. We have the density of the solution because it was given. So let's take 100 grams and we're going to divide it by the density of the solution. That's our volume of our sample, but we can't use that in molarity yet because it's not in the right form. So we have 0.0909 liters. And so molarity is 0.0486 moles divided by 0.0909 liters. So the molarity is 0.535. Okay. I don't expect you guys to be able to pull this problem off right away. I just wanted to show it to you early. We're going to kind of do these, maybe do one a day. You'll get more comfortable with it, and eventually you'll be fine with it. All right, just wanted to introduce it, though. This is how you convert from concentrations from one to another. All right, let's pause that.